Hello everybody, this lesson is from Unit 1, Lesson 5 on Function Equations Part 1, and it's really talking about how to write a function as an equation. So equations and functions, previously we've learned that an equation can be written in different forms. So the form that is shown here is actually slope-intercept form, where we can see that y is by itself. We can see that the slope of this equation is 2, and it's crossing our y-axis at a positive 1. So the equation is y equals 2x plus 1. As a function, we can write it and set it up the same way, we just use function notation. So function notation uses f of x, so a function evaluated for x, equaling 2x plus 1. Or we can write it as a function of x that points to 2x plus 1. Both of these are the same, represent that same function. And for function equations, whenever you see y, think of it as being f of x. So it's a function of x. And it's always best to write, or it's easiest to write these equations when they're written in slope-intercept form, where m is the slope and b is the y-intercept. So you can clearly see those two values. This way, if we're given a graph of a function, or a graph of a line, we can easily write the equation of this line by using slope-intercept form. So slope-intercept form is y equals mx plus b, so we can see the slope, and the y-intercept, this is a b, not a 6, but the only difference is function notation is going to use f of x. So instead of y, we're going to have f of x, and we need to find two things. We need to find the slope, and we need to find our y-intercept. So the slope, we need to identify two points that intersect on this line. So here is a really easy one that we can use. And we can also use this point here. So you can either subtract with the coordinates of those 2 points. So 0, 2, and then this point is -2, -1, and use the slope formula, which is y2 minus y1 over x2 minus x1. So you can use the slope formula, and you can also just count right on the graph if they're nice coordinates like this. So the rise, the up and down distance between those 2 points, and the run, the left and right distance between those 2 points. So rise over run, the steepness of the line, will give you the slope. So from this point, if I count up until I'm in line with the other one, that's 1, 2, 3. So we have a rise of 3, and then starting from here, there's 1, 2. So we have a run of 2. So a rise of 3, a run of 2 gives us a slope of 3/2. If I were to use the slope formula, I should also get to that exact same answer. So difference in the y values, so 2 minus a -1, and then 0 minus a -2 for the x values. Subtracting a negative, you add the opposite. So you have 3 on the top, 0 minus a -2, add the opposite, you get 2 on the bottom. So you still get that slope of 3/2. So setting up our equation, we've got 3/2 for our slope. X still stays as x, plus our y-intercept, and that's where it's crossing our y-axis. It's crossing our y-axis at a positive 2. So our y-intercept is 2. So here is our function equation. F of x equals 3/2 x plus 2. Again, you need to find the slope using the slope formula or counting, and then find the y-intercept, so where it's crossing that y-axis. One more example with this, match the graph with the function. So right away, I can see that this is a negative slope because it's slanting down to the right. So it's a negative slope. So I know that any of these that are positive where the slope is are not going to be the answer. So A is a positive slope. It can't be that one because my graph clearly has a negative slope. Looking at b, also a positive slope. So I know that it cannot be that slope. Next thing we're identifying, so we can write it in slope-intercept form. So mx plus b. My y-intercept is a -3. Both of these equations have a -3. So I know my equation is -3. And function notation, we just have to find our slope. So the difference between this point here and this point here. So the coordinates of this one is -1, 2. This one is x is 0, -3. So if we subtract y2 minus y1, so -3 minus 2, and then the x from that same point, 0 minus a -1, will get me the slope of that line. And it doesn't matter which point you identify as y2 or y1. What matters is that these two coordinates go from the same point, and these two coordinates are from the same point. If they're mixed up, then it's not pulling from the same coordinate anymore. So our numerator, add the opposite, you get -5. Denominator, add the opposite, you get 1. -5 over 1 gives us a slope of -5. So -5x minus 3 puts us at D for our correct function equation. Again, you could find the slope by counting on the graph the distance between these. So from here down to here, 1, 2, 3, 4, 5. So it has a rise of -5 from here to here, and a run of a +1. So you still get that -5 for your slope. Finally, horizontal lines or vertical lines. A horizontal line, every single y-coordinate, if you look at every y-coordinate on this line, no matter what point it is, the y-coordinate on this line is -6. So this is basically saying that y has to equal -6. Because like this coordinate here is -8, -6. This one here, -4, -6. Over here, this point here is 6, -6. You'll see that all of the y-coordinates are -6. So if you think of it as y equals -6, then as function notation, replacing y with f of x equals -6. So the equation would be b, f of x equals -6. If it were a vertical line, same thing, but all of your x values would be the same. So x would equal that number if it's a vertical line.